episode. We're excited for our new season that'll be starting this coming November. And joining our cast will be J.D. Whiskey 1 Delta Victor Zulu. J.D. is going to be performing product reviews, new product information, and everything. And we're really excited to have J.D. join the cast. We're really busy right now editing our new introduction video, new segments to kick off season 3 in November. So we thought it'd be fun for the final show of season 2 to take a look back at some of our more popular segments based on emails, questions, and comments that we've received. So come on and join us for a trip down memory lane from season 1.
Some of you might want to know where the point is where we stop yapping and start talking about amateur radio stuff. So this will be the point right here. The first one that we're going to go to is we're actually going to start with Greg's segment. And one of the coolest things that you can do is look into amplifiers, especially ones maybe with preamp. Greg, do you have something to get us into that information?
Actually, that's an interesting question. And to be honest, I'm very much against amplifiers in your shack with a preamp. And I will explain why. All right, I really like your question, Samantha, and it leads right into what I wanted to discuss today. So thank you very much. So let's take a few moments and misconceptions of preamps and how to use them. First off, in my personal opinion, I think that in-shack preamps, such as our built-into common brick amps from MFJ, TE amps, etc., are honestly a waste of money and provide no real benefit unless you're just looking to increase your S-meter reading and noise. Your time and money would be much better spent on quality, low-loss feed line and high-gain antennas. If you are considering a preamp or you need a preamp, and there are times that you will need one and they'll provide a good benefit, you need to take a look at mass-mounted preamps and use them in a fashion that's going to benefit you. Mass-mounted preamps are designed to basically provide two primary functions. Number one, to help increase the weak signal that you're bringing in to a level your radio can decipher and turn into a working, readable signal. And from my point of view, the most important aspect of a mass-mounted preamp is to overcome the feed line loss that you have in your VHF, UHF antenna system. The problem with shack-mounted preamps is that they're basically going to increase the noise in your shack. They're great for raising your S-meter level a few yes units, and with few exceptions are more or less not really useful for boosting a workable signal. Let's go ahead and go over why. All right, let's start breaking down why I have the viewpoint and opinion that I do. The first thing I want to remind everybody is that we are going to be keeping this basic, okay? We're trying to address this topic not only with the experienced amateurs who've been doing this for 30, 40 years, but the brand new hams that have just gotten into the hobby, and people who are just now looking at VHF, UHF weak signal operating, because it is vastly different than operating, say, FM2 meters, repeater operation and stuff. All right, this first picture you'll notice is my TE Systems 350 watt amplifier. This amp is used on my Simplex FM portion of the station for Simplex. And the first thing you're going to notice is it's got a preamp built in. And you're going to say, well, they sell amplifiers without the preamp built in from TE Systems. So Greg, why did you do that? Well, Greg's going to answer that question. And the simple reason is lack of patience. When I placed the order for it to replace a amp that was just not cost effective to repair anymore, was getting pretty old, they were out of stock on the amp model I wanted, which was the exact same amp minus the preamp. And so I went ahead and didn't want to wait 4 to 5 weeks for them to get those back in stock. So I went ahead and ordered it with the preamp. Now, that said, that switch has never been turned on and never will be unless someone comes in and accidentally bumps it. Okay. Now let me explain why. Let's go ahead and look at this from a basic point of view. Let's say you've got a signal coming into your antenna that's an S3. All right. Now, by the time you go through your feed line, which is RG8 to LMR 400 or something like that, and a couple 125, 150 feet, that S3 signal's now going to be an S1 or less because of the feed line loss. So your radio doesn't have anything to work with. All right. You kick on your preamp. Well, let's just flip that switch there and bada boom, bada bang. That'll solve my problem. No, it won't, because the preamp's got the same signal to work with that your radio does. Basically, nothing. All right. So you've done nothing but amplify noise and make your S meter go up. You've not brought in any workable signal to your radio. Okay. Now let's turn around and move that preamp to the top of the tower. Same exact scenario, but the preamp is at the top of the tower right at the antenna. All right. So now what we've got is we've got an S3 signal hitting the antenna, preamp boosted up to, we'll just say S6, because that's where you've got your settings. All right. So you turn around, you boost that signal up to about an S6, and now you go down, you still got the same 2 S units loss through your hard line or feed line, and it hits the radio. But now instead of a barely readable S1, you've got a workable S2, S3 signal at your radio. Okay. So you now are hearing that. Not only is your S meter going up, but the signal and workable signal at that is up. Okay. So that's the basics of why you want to move that preamp to the top of the tower at your antenna. All right, now let's look at how and why. Okay, there are about a half a dozen good manufacturers that build mass-mounted preamps. All right, in my opinion, the best one to go with is SSB Electronics. Now they're a little pricey, but you get what you pay for. Not only are they low noise, but they're also capable of handling high power if you buy the high power models. They make them ranging from 200 watt models to full legal limit models. First thing I'm going to address is, in my opinion, always buy the absolute highest power that you can afford, because while you may only be running 100 watts today, what happens tomorrow when you get really addicted to this hobby and you kick your power up to 300, 400 watts? Okay. You don't want a preamp that you're going to fry. All right. Now, one of the reasons that in-shack mounted preamps are popular is simplicity. All right. You hook the antenna up, you hook the radio up, you hook power up, you turn it on, bada boom, bada bang, you're done. Not so with a mass-mounted preamp. Okay. First thing you've got is preamp up there. It cannot handle transmit power in any way, shape, or form. Not even one little watt. It's going to go bye-bye. All right. So the first thing you need to do is, not only have you just spent, we'll say for an SSB electronics preamp, not only have you just spent $600 to $800 for a preamp, but now you got to buy a sequencer. Now, what's a sequencer do? All right, well, the sequencer, basically, when you key your transmitter, your microphone, your Vox, whatever you're using to trip your transmitter, it's going to do multiple things in a specific order and sequence. It is going to, number one, shut down and ground that mass-mounted preamp. Number two, it's going to turn on your transmitter amp. And then number three, it's going to activate your exciter or your radio. Okay, so shut off the preamp, turn on your amplifier, key the transmitter, and now you're set and you're operating. Okay, and it does that very quickly, but it's a vital piece of equipment. Now, here's the problem. You just spent $700, $800, $900 on a mass-mounted preamp. Now you got to spend another $200 to $300 on a sequencer. All right. So one of the things I did, I originally started out, I've got 2 sequencers I had in the shack at one time. And then when I started buying higher end amplifiers, such as the Bicos and stuff that you see in the picture here, I went ahead and they had the advantage of having the sequencer built in. You'll see a button on the amps, the 2 Bicos. We'll go zoom into the Bico a little bit. You'll notice that preamp button. That's not a preamp built into the amplifier like it was on the TE systems. That is a sequencer button turning the preamp on and off. So I can completely shut the preamp off in my shack right there, and it won't key up. If I put it in the on position, it now goes through the sequencer on the amplifier like we had set up. So it shuts down the preamp, it keys the amplifier right there, and then it turns around and keys the radio transmit. So it performs just like a sequencer. It's built in. And you'll notice all of my amplifiers have that except for 6 meters. My alphas do not have that on 6 meters and F, but all my VHF, my 2 meters, my 220, my 432 Bico amps all have the sequencer built in. And my Gemini amp for 1296 also has it built in, as you can see right there. Okay. And again, even though it says preamp, that's for mass mounted preamp, and that's turning the sequencer on and off. If you've got it in the on position, the preamp will work and the sequencer will run through its normal functions. If you turn it off, it powers everything down to the preamp, and that's all it does. Okay. So now let's look at a typical station with the preamp. Let's go up. We'll just go to my 2 meter. All right. First of all, I have multiple antennas hooked up to my my radio for 2 meter weak signal. Okay. So I have a stack set of K5VH Omni antennas. There's 2 of them up there phased together. That comes down to the tower top after the rotor loop and everything. And then I have a set of 15 element stacked antennas for 30 elements that I can aim someplace. And then when I want a wider pattern, I have a 17 element single 2 meter antenna. So all of those are on my mast. They come down with the rotor loops, you know, for the antenna, and feed into a remote relay box because it's just not cost effective or practical to run big, heavy hardline all the way back into the shack. So I have a sorry about that, a tower mounted relay box, remote relay box, again by SSB Electronics. And each antenna plugs in. My Omnis go into antenna port 1, my stacked beams go into antenna port 2, and my single 17 element goes into antenna port 3, and 4 is not used. So that comes out. So the antennas come in, go into that, and then I've got a short drop out of the relay box, which goes into my mass-mounted preamp, and then that plugs directly into the 3/4 inch hardline. Okay, and that comes down. Now, also just before where each antenna comes into the relay box is also a surge protector. So each antenna is individually surged, protected for static and lightning protection. And then they go into the relay box and then the preamp. And I did that for a couple reasons. Number one, it does no good to have a lightning protector before the preamp or after the preamp. We want to keep surges and static from coming into it. And that protects that. Okay. And all of that's fed down and through. So now what happens is I'm getting a good quality signal coming in over my cable, and it's matching the loss. Now, the other advantage to most mass-mounted preamps is you can actually adjust the gain, okay? First mistake I see a lot of people new to preamps do is they sit there and turn around, they've got a preamp that's capable of 20 dB gain. So they crank that puppy all the way up, they stick it on top of their tower, and they can't hear anything. Well, what's going on? Why is it hearing less than when I did before? Well, the simple answer is you're desensing your radio. You're overdriving your radio so much with a strong signal, you're actually desensing it, all right? Sort of like having your next door neighbor operate. Well, here, let's put it simply. Have you ever sat there and used a mobile and you're talking on a repeater and you got a friend that's in the car right behind you talking on the repeater and you're having trouble hearing him even though the repeater is good for both of you? Well, what's happening is he's desensing your radio while he's transmitting, plus FM capture, but that's a whole different story. All right, so you don't want to desense the radio. So now you need to adjust it. So how do you adjust this? All right, well, what we want to look at is, let's say you've got 3 dB loss on your feed line, okay? So what you want to do is overcome that loss. So we want to dial in about 3 dB gain on your preamp. All right, now we also want to boost weak signals. So where I would start at on that preamp is, instead of starting up and working down, start down and work up, okay? You'll make less trips up your tower adjusting things. All right, so in that instance, I would start out with about a 6 to 7 dB gain setting. You're overcoming your feed line loss and you're boosting some of those really weak signals that are coming in, and that's kind of where I would get started. Now, you may make 1 or 2 more trips up. You may want to increase that gain a little bit. You may want to dial it down a little bit. A lot of that depends on your radio and how it handles strong signals coming in. But you don't want to overpower the radio, basically. Okay, so as I said earlier, mass-mounted preamps add a lot of complexity to your station, but they can be a big benefit. All right, I haven't used my 2-meter preamp in, like I said, probably 2, maybe 3 years, because when I first put that up there, I had 1/2-inch hardline up at the top of the tower, about 140 feet, and then I went to 3/4-inch hardline, and that reduced the need for the preamp quite a bit. And then when we did the last work on the tower, it was all replaced with 1 5/8" hardline up the tower. I've got 3 runs of 1 5/8" going up that tower. So I have extremely low loss. So basically, when I turn on my preamp, I am really hitting my radio hard with a signal coming in and running the risk of desensing everything. There are a few stations that I've worked that the preamp was a help. They were extremely weak and I was able to boost them up, but I also had to turn the RF gain down on the radio in the shack to help compensate for that a little bit. So anyway, that's it. That's very basic, in the nutshell, explanation of the preamps and why to use them. They can be a big benefit, but before I spent money on preamps, I would get the best feed line that I can get up on that tower. Then I would look at spending money on preamps. Okay? All right, back over to you, Samantha. Okay.
Well,
I'm here with Andrea K2EZ, who is a big-time VHF, UHF rover. Welcome to the show, Andrea.
Thanks, Greg, for having me on.
You're welcome, and we appreciate you joining us here to help us out. So can you tell us a little bit about what roving is and exactly how it works and what's involved with it?
Okay, well, roving refers specifically to one category in the VHF contest, VHF, UHF contests, even extending into microwaves. And a rover, very simply, is a station that moves from one grid to another grid during the course of the contest. So most of the stations in the contest are fixed. So as you can imagine, given the generally limited ranges you get on VHF and UHF, it can get kind of tough to find new stations by the end of the contest. There are certainly band openings that occur, and a lot of people don't understand how the band openings work in VHF and how you can get much further than line of sight. But as a rover, during the course of the contest, I'll go on a hilltop as an example, and then I'll work all the stations I can. Then I'll run over to another grid. And as soon as I change grids, I am a fresh station that contest operators can work. And so for the course of the contest, I'm always someone fresh that people can contact. As a rover, I have to transport all my equipment and my antennas in my vehicle. And often one of the values rovers provide is some ongoing activity, but also activating a grid that may not have a fixed station operator in it. So that is something that is very valuable to the operators in the contest.
Okay. Yeah, I'm going to tell you, I thought that I was fanatical about VHF, UHF until I saw your rover for the first time about 5 or 6 years ago. And I'm going to say you set the bar very high. In fact, I didn't think you could operate some of the bands that you're operating on from a mobile like that. What originally attracted you to roving? I mean, that's kind of an extreme sport of this sport.
Well, I often say I kind of fell into it accidentally. I've I've been an amateur radio operator for 40 years now, and never really even did weak signal VHF, UHF. Certainly had not even given microwaves a thought. They weren't even on the horizon. I knew something about 2 meters sideband and better performance and stuff, and but I didn't mess with it other than some dabbling with satellites back in the 90s. And so I fell into it accidentally. I was going on a road trip. My first real long distance road trip, I'd been out to basically east of the Mississippi. And I was going to visit my daughter in Utah, and I had planned a trip to visit friends in Minnesota all along. And so I had HF set up in the car, and I heard this VHF contest was going on. And I'm like, well, it's easier to make VHF contacts, than HF contacts from the mobile. And so I had this radio from satellite days, which gave me 2 meters, 1¼ meters. I had another rig that gave me 70 centimeters, and my HF rig did 6 meters. And I'm like, well, there's 4 bands that are in the contest. Let me put this rig in the car and add it in there. And I just made some little horizontal dipole antennas and decided, okay, I better look at the rules, make sure this is operating mobile is legal in the contest. And I start looking through, and I discovered this rover category, and specifically a limited rover, which is low power, 4 bands. And I said, perfect, I've got 4 bands. And so I understood, the grids, and so I looked at my route, and I'm like, okay, I can adjust it here to hit a couple more grids, and well, I'll just do this during the contest. And the first day was a total disaster. I didn't know what I was doing. I had a hard time making contacts. I wasn't copying very well. I mean, I had 25 watts. I did have horizontally polarized antennas, which I knew was important, but they were just dipoles. And 6 meters was vertically polarized. I used my Tar Heel for that. And but at one stop, there was a bunch of ignition noise stuff. I'm like, this thing has to have a noise blanker. I couldn't find it on his FT736, which has a million buttons. And so I finally got out a flashlight because I couldn't see it in the car otherwise. And I found the noise blanker and I pushed that, and suddenly I could hear people like 10 times better. And from then the contest got better. I had my first 4-band sweep, because when you make contact with one station, typically 6 meters or 2 meters, you QSY through the rest of your bands. And so people would say, you know, do you have any other bands? And that's kind of a staple question if you haven't worked somebody before. What other bands have you got? And so I had my first 4-band run, and the next day I started out in the snow, but there was a whole bunch of activity in the morning. So I'm operating while driving in the snow. And I found people were starting to follow me. When do you get a new grid? And suddenly they were all interested in this. And I was like, well, this is great. You know, it was a lot of attention. I just had a lot of fun. I only worked like 78 contacts in that contest. But I'm like, okay, I'm going to have to do this again when June comes around. That was the January contest. June is actually the biggest contest of the year. And while I'm saying it, September is the third major contest. There's a number of sprints, plus the CQ Worldwide, which is mostly a 6-meter contest, but has 2 meters as well.
Yeah, you know, you say that. I have never had luck during the September contest out of this location. June, I've come in first place a couple times, and the January one, I don't do too bad, but September, I don't know why. I don't ever have any luck with that contest. On some of the contests and stuff, what are some of the what's kind of your average number of contacts?
Well, it certainly has grown, and to put a perspective on that, limited rover, I typically was getting about 300 contacts, 270 to 300 contacts through a number of contests. And that was enough to get me well within the top 10. Multipliers play a role. And of course, the different grids you go to are multipliers. For my really good efforts, the ones that I actually got first place in limited rover, I was right around 500 Qs for the whole contest. Certainly not like an HF contest where you're churning out, you know, multiple contacts a minute. You might get a few contacts like that, QSYing with a station, but those occurrences are pretty rare. As I've gotten into classic rover is all the bands up into the microwaves. I'm getting about 500 Qs now.
That's not bad.
Excuse me, I said 500 again, didn't I? I meant 800 Qs.
Yeah, that's pretty healthy performance and stuff. I think my best contest was about 712 here at the house, and
Yeah.
on there. So you know, and interesting enough, that was 2009.
Wow.
Was the best one, and it was my second contest. So. What was some of the, besides the obvious, when people see your antennas and everything, but what are some of the major obstacles you ran into, both in actually roving and in building your rover?
Well, the rover I've been building, 2015 was that first contest, excuse me, and in June was the first time I started using this vehicle. So it's been just about 5 years. And it's been a progression of steps along the way, starting out with omnis and then stacking omnis, horizontal loops, and then eventually adding the Yagis on there. But I think one of the first obstacles I encountered was getting people to know I was out there. I didn't have a lot of power, and it does help for stations to know that you're out in the area. It's not absolutely necessary, but it really does help. Another one that I encountered the first several contests, it took me a while to sort it out, was logging, how to log. That first contact, I was using a paper log, and it was tough to log. And then the post contest operation was just terribly time consuming. And that was with 78 contacts. Software for computer is fine when sitting down, but the software always wanted to log the last band you log something on, because they're all designed for contests of running continuous on one frequency. But in the VHF contests, you're hopping up and down the bands. And so almost no two contact in a row is on the same band. And the number of errors I made was just crazy. And then trying to log, having to pull on this, fit when you're sitting still, you're fine. But if you're moving and you log somebody, then suddenly you're pulling off to the side of the road. So I ended up writing my own software to get around that. Ergonomics, that was not a great big, it was a challenge because I had to think things out as the system got more complex. I had to make sure that I could operate and not affect, my ability to drive and pay attention on the road. I got to tell you, I have to pay a lot of attention to the road, because the way people react to the rover, and they drive erratically, taking pictures and hiding in my blind spots to check out the vehicle. And so I have to be up on that. RFI was another one. You've got a lot of equipment and antennas in a small area. The rigs at the power levels I was running didn't really, they overloaded each other, and except for 2 6-meter rigs and antennas that were about a foot apart, where I blew out the finals on one rig with transmitting by the other, I never had a problem with that. But RF would get back into the cables between the rigs when I had amplifiers into that, the key up of the amplifier. Trying to use an RF sensed amplifier, you transmit on 2 meters, and the 2 meter RF goes down the 70 centimeter antenna through the amp and triggers the RF sensing circuit. So the amp's going click, 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 because once it clicks, it loses the connection. It drives you batty. And so I had to overcome that. And as the system grew, I eventually ran into this problem of, well, I wanted to add the Yagis, but I had the Omnis that were serving me so well in the back. And so how am I going to mount the Yagis, provide all the structure, be able to rotate these while on the move, because that was a design choice that I made, be able to withstand my design goal of 125 mile per hour wind, because some parts of the country, like Wyoming specifically, where I'd been, you have an 80 mile an hour speed limit and you get some headwinds and stuff. So I needed to get all that mounted, and then I needed to be able to switch between the Yagis and the Omnis. So making all that antenna switching, that was one of the challenges. I could also add going into the microwaves. I had to think, well, how can I do feed lines at these frequencies and so on. But there's lots of technical challenges for sure. But the basic limited rover, not that hard to get into.
Well, on your station, the biggest fear I would have is trees. I
Yeah, watching out for trees, that is the biggest thing. I've had my 2-meter Yagi, which is at the top, get fishboned a few times. It's usually after rain. It's in the spring where the leaves are hanging lower before trucks have brushed them off, and after a rainstorm, that's where I have to watch the most. I've got a pretty good calibrated eye, but sometimes in the dark, you watch out. I did take out a cable TV cable once that was hung low across the road. Everything's supposed to be above 14 feet. This one was somewhere around 11 feet, and it hit the mast. Didn't do any damage, but it kind of knocked the Yagi catawampus on me, and I had to bend things and get it back.
yeah, I bet. I have taken out more of my. I run the K5VH Omnis on my truck, and neighborhood trees and trees up at the ranch have more than once taken out my Omni antenna on there. They don't have the flex like a whip does on that.
Yeah.
Just out of curiosity, what's probably the longest travel distance you've done on a roving trip during a contest?
The longest single contest was my January 2016, so it was fairly early, and it was after quite a bit of upgrades. I was still just running the Omnis, and that was a 1,700-mile rove starting central Pennsylvania, going up towards the Great Lakes, picking up a little bit of New York, across Ohio, out to Dayton, little jog north to catch grid in Dayton, then run down through Ohio into Kentucky, then Tennessee, into Arkansas, and then into Texas, where I didn't take the shortest route to my destination because I wanted to get to the DFW Metroplex, and then from there, finishing the contest right on the outskirts of Houston. It was total activation of 27 grids in that contest. And that actually set a record for the most number of grids in a submitted log. I've heard rumors of 30 plus grids, but they weren't in a log that ever got submitted. And that was about 29 hours of operating time with about 4 hours downtime for sleep.
Wow. More power to you. I have enough trouble doing the contest right here in the shack, so I don't think. Now it would be fun to do the roving, but I think it takes a special kind of person to go after that. Why don't you give us a tour of your ham shack and stuff? I know you've got some prepared pictures for us, and let's go ahead and kind of review those and go over them.
Okay, sure. The first photo here is an annotated version of Rover, showing all the antennas marked, the 7 Yagis on the front of Rover, and the Rover I use as a proper pronoun for the vehicle ever since I hung the signs that say Rover on the side. In the center, I have my HF antenna, and outside contests, I do quite a bit of HF operation. Almost invisible, but marked there are a bunch of vertical whips, including a CB antenna. And then on the rear mast is the horizontal loops for 6 meters at the top. They're stacked 2 meters, stacked 1¼ meters. And then I've got 2 loops that are kind of standing on end. They're semi-directional for 70 centimeters, and one gives me a front rear pattern, one gives me a broadside pattern. That is something unique. A lot of people ask me questions about.
Yeah, I always wondered kind of why you had a couple antennas set basically on end like that.
I found that that loop is, so quote unquote, a dual band loop. and it's supposed to work for 2 meters and 70 centimeters. I had one originally sitting normally in the horizontal plane for 2 meters and one for 70 centimeters. And I called up the manufacturer one day and asked, well, what's the gain on 70 centimeters? Because it's bigger than a natural 70 centimeter loop, because it was a 2 meter loop used on the third harmonic. And they said, we don't know, it just tunes up okay. And I'm like, okay. So I did some analysis. I would expect, because it was bigger, that there's more capture area and it would exhibit some gain. What I discovered was that on 70 centimeter, it was essentially shooting all the energy straight up. And I'm like, that's not good. And then I sort of played around with it and I said, what if I put it on its side? And what I came to learn is that that large loop behaves much more like a full wave loop than a half wave loop. A full wave loop radiates perpendicular to the plane of the loop to a large extent, whereas a half wave loop favors in the plane of the loop. And so these, I stood them on end, looked at what the analysis said, and it said I should get some gain. It's about 120 dB, excuse me, not 120 dB, 120 degree, 3 dB down beam width, which means with one facing front rear and the other side to side, there's quite a bit of overlap. And on the 45s, they'll perform about the same. And they're only about a dB or so down from the peak. And when I'm solidly in one versus the other, it's about 6S units difference I can have between the two antennas if somebody's in the null on one of them. And it was a semi, I think of it as a semi-omni solution, because there were just two switch positions. I flipped back and forth. If one worked, I'd stick with it. If it didn't, I switched to the other. That simple.
Okay, well, you answered my question, so I don't need to answer my next question. I was going to ask you if you had those phased or was switching them back and forth.
Right, it switched. This next photo here is of the front seat, actually looking at the center console and the passenger side. As you can see, there's no room for a passenger. And in the center console, you've got my FT450, which is my HF, and my 6 meter rig. Immediately to the right of the FT450 and a little bit down, you'll see the control head of an IC7000. I use that almost exclusively on 70 centimeters. It is my backup 2 meter and my backup HF and my backup 6 meter rig. Above that IC7000 is the venerable FT736 that I had gotten back in the 90s. Oh my God, how long ago that was. Brand new. And that's my primary contest 2 meter rig and 1¼ meter rig. Above that, you see a monitor which is mounted to the dashboard, which is my console for a flex radio, which is in the back seat. And with that flex radio, I can use it on 6 meters, I can use it on 2 meters, but pretty much only use that for digital modes. I haven't done a whole lot of digital modes, but that lets me do digital modes without the RF getting into all the interconnect wires. I do use the flex radio predominantly for the microwave bands where the pan adapter helps me find other stations. Frequency accuracy on the microwave bands is very poor in general, unless you GPS lock it. And even if you're locked, there's no guarantee the other station will be locked. So I use that very much on the microwaves, and it helps a whole lot. Not really seen here, well, just above the FT450, on top of it is Morse code key. that I got from my grandfather. He was never an amateur radio operator. He wanted to be, but he had a tin ear and could never pass the code. That key dates back to the 30s, and probably my most precious thing I've got in the vehicle, to be honest. It works well, and I keep telling myself I should find another key for the car. And just above the key, kind of down by the consoles, is an old IC 900 that's got 4 bands, 6 meters through 70 centimeters, and that's FM only. And I'll have that on and off during contests, so I can listen on 5.2, 223.5, 446. Not so much 6 meters, but because most people on 6 meters also tend to be HF plus 6 meter rigs, so they have sideband, whereas a lot of people on some of the other bands don't necessarily have sideband. This next photo is of the back seat and shows what I call the flex deck, which is the one that's hanging on the back of the seat. And the big back box is the flex radio. Next to it is a 2 meter LDPA. The flex radio supports 2 meters natively. It's flex 6700, but only low power. So that little amplifier is needed to bring that up to 70 watts. There's a switching network to the left of that, and a couple RF switches below that let me select different 6 meter rigs and different 2 meter rigs. In the horizontal level you see there, those are my transverters. On the far left is the 23 centimeter, and then I have a speaker, a little switch that lets me select between the transverters, and then I have one for 13 centimeters, 9 centimeters, and then on the right hand side, one for 33 centimeters. This next photo here is, you see the transverters on the upper deck. The lower deck, which is quite a bit older in terms of the evolution of the vehicle, has my amplifiers, which include a 90 watt amplifier for 70 centimeters, a 100 watt amplifier for 1.25 meters, and a 160 watt amplifier for 2 meters. Also on that same level, but not visible, is the RF deck for that IC 7000. This photo here is interesting. It shows some of the construction of the rotator assembly, mast, thrust bearing, and supports for the thrust bearing that take the wind load and transfer that back to the roof rack of the vehicle. I have 7 Yagis mounted. I had to count them real quick mentally. Yes, 7 Yagis, 2 meters, 1.25, 70 centimeters, 23 centimeters, 33 centimeters, 13 centimeters, and 9 centimeters. And just for reference, 33 centimeters is 902 megahertz, 23 is 1296 megahertz, 13 centimeters is 2304 megahertz, and 9 centimeters is 3456 megahertz. One thing about this installation that isn't obvious to the casual observer is that from outside the vehicle, they're mounted to the front. Almost all Rovers that you see will either mount them like the Yagis off the bed of a truck or off the trailer hitch. But I already had working antennas there, so I was kind of stuck. Well, what am I going to do with these Yagis? I'm going to have to mount them in this more difficult to place location. So I did this, and I had a side benefit I did not expect, which is that from the driver's seat where this picture is taken, I just had to look up and I knew which way my Yagis were pointed. So even though I have the rotator controller down on my right-hand side next to the console, I don't ever look at that controller unless I'm stopped and I'm kind of playing around and I know a station's at a certain location. But on the move, it's like a quick glance up, like looking at the speedometer or something, you know, which way is it pointing? And I usually have some idea what direction I'm heading on the road. It's a highway, very rough idea, but then I'll know certain stations are either mostly to the north or to the east or whatever. And I just kind of crank in and I say, okay, it's got to be to the left of me a little bit. And I swing it around there. The Yagi has a very fast rotation rate. I can go from 180 degrees in 20 seconds. So I can search pretty well with that. This photo shows the cable bundle running up to the rotator, 7 coaxes plus the rotator cable is in there. Most of those coaxes LMR 400. There's one length of Belden 9913, and there's 2 runs of MNP Hyperflex, which I use for the 2304 megahertz and the 3456 megahertz. That stuff is quite a bit thicker diameter. It's very similar to LMR 600, and that's what I needed to get the losses low enough. With regard to the coax, one day looking at these bundles, I got to wondering how much coax do I have in this vehicle? So I started adding it up, and the total as it stands currently is 535 feet of coax in the vehicle. This photo shows the coax switching network and the control box. The switching network is some N-type relays. I think there's 5 of them or 6 of them. Some of them are cascaded, and the output from the radio goes to these relays. And from in front of the car, I can select whether I want the Omni or the Yagi. And this lets me handle a lot of that front rear switching that I mentioned was a challenge. On the 2-meter antenna, I have selections, or 2-meter rig, I should say, I have selections of the Yagi in the front, the stacked loops on the rear mast, or a vertical dipole that I have off the side of the rear mast. And I use that vertical dipole far more than I use the 5/8 wave vertical on the roof, mostly because it's higher up, and experience shows it works a little bit better. And so that's the one I have hooked up to the contest rig that's got the amps and everything. Power for all the amplifiers and the radios can be quite a bit of challenge. And this photo here shows where I've located a secondary battery in the back seat of the car close to the radios. I have 4-gauge wire running from this battery to the battery at the front of the vehicle, and I have a charge controller. Under normal conditions, I usually isolate the batteries, and the charge controller limits the charge going to this secondary battery to about 20 amps. During a contest, I'll actually bridge them both together because the 20 amps charging of this extra battery cannot keep up with the use during the contest. The output of the charge controller actually diode ORs the 2 batteries together. And when I draw high current peaks, they mostly come from this local battery because the wire drops in that 4-gauge will cause current from the main battery to drop down. The vehicle has a 160 amp alternator, and this means with this secondary battery here, I don't get those big currents reflected back to the alternator.
Man, I'll tell you what, that is some of the most fascinating setup on there. Your 736 takes me back. That was one of my favorite rigs, and it was my first real weak signal sideband rig for 2 meters. I had 2 of them, one with the 2 meters and 220 module in it with 432, and then another one that I used on 1296. So I could do 220 and 432 and 1296. I love that radio. Really want to thank you for joining us today and appreciate your time. Any last minute advice for anybody wanting to get into roving?
I think the best advice is try and find out who's out there and kind of reach out to either another rover or a fixed station. One of the things that has really motivated my interest is how tight-knit the community is. And I mean tight-knit in that they're enthusiastic, in that they're very helpful at getting other operators to come on. Anybody who's willing to listen and operate, because you don't have that whole world to work people. You know, there's a set of operators that will look for the conditions when there's some enhancement and go trying to make those contacts. I've made contacts for my mobile of about 1,000 miles on 2 meters from Texas to Florida. With my Omnis, I've made contacts from Tennessee down into Texas. So understanding a little bit who's out there, kind of reaching out to people. One of the things I did to help get known is I looked through the contest results at the top operators for each area that I was going through. And I looked them up on QRZ, send an email and say, hey, I'm planning on roving in your area. Do you have any tips or suggestions that you might offer me? You know, this is who I am, this is my call, and this is what I'm operating. And I got stations like K2EZ in Maryland. He had helped me a whole lot. K5LLL in Texas, K5QE in Texas. These people came back to me and wanted to talk on the phone and gave me lots of input, and that probably has influenced me, got me engaged a whole lot more than I otherwise would have. And I also have a lot of fun getting out to the VHF conferences that take place. There's a number of them. There's a Northeast Weak Signal group up in New England. There's Pack Rats in generally Philadelphia area. They have a yearly conference. There's the Southeast VHF Society. They have a conference. Central States VHF has a conference. There's one out on the West Coast that can't remember. There's Northern Lights up in, I'm thinking Wisconsin, Minnesota area. There's they don't hold a conference, but there's the Roadrunner Microwave Group, which I think you know locally here.
Yeah.
I've met a lot of wonderful people that are enthusiastic about weak signal VHF. And
oh, yeah.
I can't emphasize how much it is great to reach out to some of those
You're
people.
right. They go out of their way to help you out and stuff. I met with Marshall one time at his station, just gave me a tour of his station, his antenna towers, and I think we spent 3-4 hours pushing all the benefits of VHF, UHF contests. That's a man who is dedicated. And
that is for sure.
I loved his sign over the door of his shack with real hams don't use HF. on that. Andrea, I want to thank you very much for joining us. I really appreciate your time tonight, and hope you have a good luck, and get us your schedule, and we'll get it out with the hamster events for the next contest that you're doing, and you're going to be roving again.
All right. Well, thank you very much, Greg. I appreciate it. And I've had a wonderful time talking with you.
Thank you very much.
And I hope the listeners enjoy it as well.
Well, I hope so, and I think they will. Thank you.
I can say your call sign in Russian. Nikolai 5 знак Olga.
I like that. Okay, well, let's go watch that video that Raisa brought to us, and let's take a look at that.
Let's go. The idea to make this video came from my subscriber. They asked me to give an advice how they can find the Russian national phonetic alphabet, which will be used in the QSO with Russian radio amateurs. And I decided to make this tutorial video for you. I want to be helpful for my subscribers. Mostly we use for the spelling of the letter Russian female and male names. For example, Alpha, Anna, Anna. Bravo, Борис, Борис. Charlie. It is an interesting case because the word is цапля, цапля. It is a kind of birds. Delta, Dmitry, Dmitry. Echo, Елена, Елена. Foxtrot, Fyodor, Fyodor Lvov was the first Russian radio amateur. Golf, Galina, Galina. Hotel, Hariton, Hariton. It is a male name, but very, very rare name. I don't know nobody who has this name. Juliet, Yot, Yot. Or Ivan Краткий, Ivan Краткий. Kilo, kilowatt, Konstantin, kilowatt or Konstantin. Lima, Leonid, Leonid. Mike, Mikhail, Mikhail or Maria, Maria, while Maria. November, Nikolai, Nikolai. Oscar, Olga, Olga, with the soft pronunciation the letter L, Olga. My Germany friends will do it in the right way, I'm sure. Papa, Pavel, Pavel. Quebec, Quebec. We have known this letter in our Russian alphabets. Quebec will be щука, щука. It is a pike, the fish. Radio, Roman, Roman. Radio, radio, or Raisa. It is a joke. Don't use Raisa. Please use only Roman or radio, radio. Sierra, Sergey, Sergey. Tango, Tamara, Tamara or Tatiana, Tatiana. Uniform, Uliana. It is my favorite Russian female name, Uliana. Victor, Жук, Жук. It is a beetle. Жук. It is a beetle. Whiskey, Vasily, Vasily. X-ray, знак, знак or X, X. Yankee, Y, Y. I think it is simple. Zulu, it is female name Zinaida. Zinaida or Zoya, the short version of this name, Zoya. Can I continue? Of course, for the QSO we need the numbers. And the numbers it's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9 and 10. I hope it was an interesting video for you. If you like it, please give me your likes and put your comments below what else can be interesting for you, my friends. And now I would like to offer you a flash mob. Now, after this lesson, you know how to spell your call sign in Russian language. You can record short video with your call sign with Russian letters and upload it in the stories in Facebook or Instagram. And don't forget, mark my hashtag Raisa. After that, I will repost your stories in my stories and we will have a little fun. If you like it, of course. Let's start. Ульяна, Боря, 1, Anna, Olga, Anna. 73 and 88.
All right. Well, thank you very much, Raisa. Any final words for our audience?
And I wish you nice watching my short video about Russian phonetic alphabet. And also I wish you enjoying our hobby and hope to see you once more. And of course, I will be very happy to see you on the air. And now then the propagation every day stayed a little bit better. We will have more opportunity to have QSO with the station with USA. And I will be very happy to have this QSO.
Yeah, I'm looking forward to having a QSO on the air with you on 20 or 17 meters sometime too.
Yeah, it will be great.
Very much. Thank you very much for joining us, and you have a really good evening, I guess.
Thank you, and have a nice day. 73 and 88.
73.